a robust approach for brain tumor detection in magnetic resonance images using fine-tuned efficient net. So now coming to the introduction part. In the realm of medical imaging, the precise and timely identification of brain tumors is crucial for effective diagnosis and treatment strategy development. In responsive to the vital requirement, an innovative solution utilizing fine-tuned efficient net for the detection of brain tumors in magnetic resonance images, that is MRI, has emerged. Magnetic resonance imaging, offering high-resolution visualizations of soft tissues, serves as a pivotal diagnostic tool for recognizing abnormalities in the brain. So now coming to the objective part for this project is to notably enhance the accuracy, efficiency and dependability of diagnostic procedures in neuroimaging. Conventional approaches to brain tumor detection frequently encounter difficulties in accurately outlining abnormal tissue structures within the intricate and diverse landscape of MRI scans. The incorporation of fine-tuned efficient net seeks to overcome this limitation by leveraging the capabilities of deep learning to improve the sensitivity and specificity of tumor detection. So now coming to the requirements part, here we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirements part, Anaconda 3 is required and Visual Studio Community version is required. So now coming to the flow of project. Here first we have importing the packages. In this module, necessary libraries and packages which are NumPy, Pandas for data manipulation, sklearn to facilitate machine learning and matplotlib and C1 for visualization are important. Second, here we have exploring the dataset, brain tumor dataset. The brain tumor dataset is loaded and explored to understand its structure, checking for missing values and gain insights into its features. Next, here we have image processing, using image data generator, rescaling the image, adjusting the scale of the image, shear transformation, applying the shear transformation to the image, zooming the image, modifying the image by zooming, horizontal flip, creating a horizontally flipped version of the image, reshaping the image, adjusting the shape of the image. MobileNet, a pre-trained deep learning model for image classification. The next here we have building the model, Inception V3 MobileNet, Exception Efficient Net V0, VGG16, Inception, ResNet V2, ResNet 50, GoogleNet, various pre-trained models for image classification, Ensemble model, Inception plus MobileNet, combining prediction from Inception and MobileNet models. The next here we have training and building the model. The models created in the previous step are trained using the data set to adjust their parameters for accurate prediction. And the next here we have importing the packages. Similar to the initial step, this likely refers to importing the necessary packages for specific environment, possibly in a different setting like Colab. The next here we have exploring the data set. In this we have reading the image, loading and reading image from the data set. The next here we have plotting the image, creating visualizations of the images. Then we have image processing, converting to blob image objects. In this, converting images to blob objects, defining the class, specifying the class of object, declaring the bounding box, defining the bounding box for the object, convert the array to a NumPy array, converting array data to a NumPy array. The next here we have loading the pre-trained model, reading the network layers, loading and reading the layers of the pre-trained model, extract the output layers, extracting the output layers of the pre-trained model. The next here we have image processing, appending the image, annotation file in images, combining image data with annotation files. The next here we have converting BGR to RGB, adjusting the color format of the image. Then we have creating the mask, generating a mask for the image, resizing the image as adjusting the size of the image. The next here we have data augmentation, randoming the image, applying randomization to the image, rotating the image, and next here we have transforming the image, applying transformations to the image. 12th here we have installing the packages required for YOLO V5 in Colab, setting up the necessary environment in Colab by installing the packages required for the YOLO V5. Next here we have processing the data based on the YOLO V5 model, preparing the data specially for the trained YOLO V5 model. Next here we have building the model in Colab, YOLO V5, constructing the YOLO V5 model. And then we have faster RCNN, building the faster RCNN model. Then we have training and building the model. Training the model created in Colab using the prepared dataset. Then we have Flask framework with SQLite for sign up and sign in. Setting up a web application using Flask and incorporating SQLite for user sign up and sign in functionality. Then we have importing the packages. Similar to the initial steps, this likely refers to importing the necessary packages for the Flask application. Then we have user gives input as an image. User provide input in the form of an image for the model to make predictions. Then we have the given input is pre-processed, reshaping the input image, adjusting the shape of the input image, converting image to array using terras, transforming the input image to an array using terras. Then we have trained model is used for prediction. The pre-processed input is fed into the trained models for prediction. The last one here we have final outcome is displayed through front end. The model's prediction are communicated to the user through the front end of the web application, providing the final outcome of the image-based predictions. So now coming to the execution part. To execute the project, first we need to open the code folder. So here we have a folder which is named as templates. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc. which represent different pages of the website. Another folder named as static. This folder consists of files related to CSS, JavaScript and Bootstrap files. Then .ipynb file. It is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows the users to write and execute code in individual cells, making it a popular choice for data science. Next, this is app.py file which likely contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database and generating dynamic content to be rendered in the HTML templates. And the signup.db file, this file appears to be the database file which is used to store the information. So now just click over here and copy the path. Open the Anaconda prompt. Type the cd command followed by a space and just paste the path over here and now hit the enter button. Now type python app.py and now just hit the enter button. After running the app.py file, the Flask framework will host the application link locally at the default address and port 5000 unless configured differently. So here you can see that the link has been posted over here. Just copy this link and paste it into any of the browsers. Here I am using Chrome. Just paste the link over here, now hit the enter button. So here you can see that this is our home page for the MRI. Here you can see that there is a button for login. Just click on this button. Just enter the username over here and the password which you have created while doing the registration and simply click on login button. So here you can see that it is asking for uploading your image to be classified. Just click on choose file button and upload the image. So here you can see that we can choose any of the image from this. So here I am choosing this image and now click on open button. So you can see that the image has been uploaded over here and now simply click on upload button to upload the image. By scrolling down below here you can see the prediction for the uploaded image is showing as based on the input the patient has brain tumor. So depending upon the image you're providing over there it will show whether the patient has a brain tumor or not. By clicking on the try again button you can try with uploading the another image. Let's click on the choose file button and suppose here I am choosing this image. Now click on open button and click on upload. By scrolling down below here you can see it is showing the result as based on the input provided the patient has brain tumor. So depending upon the image you're providing over there it is showing whether the person is suffering from the brain tumor or not. So here you can see that there is a button for graph. Just click on this button and by scrolling down below here you can see that there are many different graphs. Based upon the graphs here we have used the algorithms which will detect the precision, recall and F1 score of those graphs. Here you can see that there is a button for sign out. Just click on this button, you can successfully log out with this. So now coming back to the conclusion part. In summary, creating and applying a resilient method for brain detecting tumors in magnetic resonance images, that is MRI, through fine-tuned efficient net represents a significant progress at the crossroads of medical imaging and deep learning. This inventive strategy, driven by the goal of enhancing precision and dependability in brain tumor diagnosis, holds great potential to transform clinical practices in the field of neuroimaging. So here we have completed with our project. Thank you.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.